In last class, we discussed about piggybacking. We just started
Yes.
piggybacking, right?
Yes, sir.
So if you see the piggybacking mode, right? So here, basically we will send the data, okay, from host A to host B. So usually in the previous mechanism, what we did, like we also send the acknowledgement, right? I mean, we were not sending the new data until we receive the response. So in the piggybacking mode, what it does, so we may receive the data, okay? I mean, we get the acknowledgement usually in the previous method, but in the previous methods, what used to happen, if the data is wrong also, we may get response, right? I mean, we are not validating the data. In that scenario, the piggyback mechanism helps. So whatever the data the receiver receives, that same thing he will send it back to transmitter. So along with the data. So what transmitter does, so he verifies whatever the data he has sent. So whether the receiver also, host B also received the same data. If both are matching, then he will send another acknowledgement. So that like the whole transition is transmission is completed. Okay, here it is
Yes.
taking little time, delayed version, but here it is more accurate way of transmitting. So I mean, is this a better way, video transmission or audio transmission? No, right? I mean, if you keep sending the acknowledgement data back again to the transmitter, then you will not achieve the high data rate. Right? So it may be used for secured, controlled environment, like maybe for instance, like if some flight has to land somewhere in the, then if you want to properly analyze whatever the coordinate he is landing, is it correct or not? So that kind of secured communication, this kind of mechanism you generally use. Okay.
Yes.
And next is HDLC. I think like previously also we discussed this HDLC a little bit.
Frame. Yes,
It
sir.
is like
Frame.
basically two types of HDLC we discussed. One is byte stuffing. I mean, if whenever we are sending bytes of data, if we see that like same byte, I mean multiple times as a header, then we actually stuff the header. As and like in the bitwise, if the header word is repeating, what we do, we add extra ones so that header is
One.
not repeating. Right?
Yes, sir. Yes.
So here they are saying like they are going little deeper. So they are like having two mode. One is normal response mode, and another is asynchronous mode. In the normal response mode, what we do, we send the command, we get the response. Whereas in asynchronous mode, we send one command. Here we multiple nodes are there. Everybody will send the response. So that is
Yes.
actually so not actually asynchronous mode. It is normal mode only, but like this particular image what I have shown, whether it is point to point or point to multi-point. I mean, here one guy is listening, here multiple guys are listening.
Yes.
So if you see here, like in his unbalanced mode, what happens? Like primary sends command, secondary will send the response. In the balanced mode, everybody can send commands and response. Okay. So if you see here, unbalanced configuration, primary initiate transfer to secondary, and secondary may only transmit data in response to command from primary. Okay. So used in the multi drop lines and host computer as a primary and terminals as secondary. This is like let me consider website. In the website, you will have somewhere the website is hosted in the server. So whenever you request some data from the server, so it will serve you the data, correct? But it is not like your local PC also serving some data to the server. Master is server only. So server will be sending data. Terminals, I mean, our local PCs will act second. Okay. So in the asynchronous balanced mode, that is ABM mode, link is point to point, and each station can function as the primary or secondary. You can see here. So anything can be primary or anything can be secondary. That is balanced.
Yes.
So generally in the frames, right, SDLC frame, we have three types of frame. One is information frame, supervisory frame, and unnumbered frame. Okay, so information frame, so iframe especially used for transport the user data and control information relating to user data. So it is actually purely iframes are used for sending the user data itself. Okay, in the sense like
Yes.
for example, if I want to transmit voice or audio, or voice or like audio data or video data, user data, so iframe will be used for that. So S frames are used only for transport control information. Can you give some example for control information? Like address, IP address, right? Where the packet has
Yes.
to direct. So that kind of data. U frame, user management. So user can define for what purpose you want to use. Okay, you can see here flag address control user information. Here flag address control FCS and flag. That is S frame. So if you see here FCS, that is control information. Here U frame management information that you can define what you want to say. Okay. See here in the flag actually it is like the boundaries address where you want to send. Control usually if you see here, so control is used for flow control and error control.
Yes.
Okay. And in the FCS, HDLC, it is actually error detection. So it is something like CRC, what we send, right? So we know how to calculate the CRC, correct?
Yes, sir.
So you can see here, the first bit of the control field is always 0. That is presence of 0 at this place indicates that it is I frame.
Yes.
Bit number 22234 in a control field is called N of S. That specifies the sequence number of frames. So first frame, second frame, third frame, like the sequence number. So what is the maximum sequence number I can have in the I frame? 7, 0 to 7, correct?
Yes.
You can see here. Since it is 3-bit, maximum I can have 1, 2, 3, 4, 5, 6. That is 1, 1, 1.
Yes, sir.
Okay.
So control field means?
See, actually, our iframe, we have this iframe, right?
Yes.
So it is totally 8-bit frame. Okay.
Yes.
8-bit. So in that 8-bit, 1 bit, MSP bit is 0. And this 3 bits, right? 3 bits. A control field means this one actually. Here we have control field, na? This one.
Yes, yes, sir.
Got it, na?
Yes, sir.
So that control field in S frame how it looks, S frame how it looks, U frame how it looks. That here discuss.
Yes, sir.
Got na?
Yes, sir.
Yeah. So here that is actually 3-bit, 2, 3, 4, and in the 5th bit is called pole or final. Okay, so it is actually two cases are there. It means pole when the frame is sent by a primary station to secondary station, then that frame is called pole. Okay. Final is actually when the frame is sent by secondary to primary. So this represents pole or final. It will be like whether that I frame is by primary node or secondary node. So it represents that.
Yes, sir.
Okay. So actually 6, 7, 8, right? So 6, 7, 8, basically that last 3 bit represents the return sequence number expected. In the sense, here, for example, if I'm for this particular command, whatever I'm sending, if I'm expecting some other response, right? What frame number it is. So for that, actually, last 3 bits I use. So, for example, from primary to secondary, I send frame number 3. Okay. In response to that frame number 3, if I'm expecting some frame number 2, then I will mention here in this field.
Yes, sir.
Got it, no?
Yes, sir.
So here some of the control response flow. Actually, I mean, this is like you can just go through, but like it is not that important. I mean, they will not expect in these details. Okay. So I mean, what is
Okay,
the control flow expected in like various scenarios? If this particular control code is there, what it means?
yes,
So then we have S field, S
yes, sir.
S frame flag, right? S frame, what are all the fields? S S frames control field actually. Okay, S frames control field. This one.
Yes, sir.
But MSB, see in the I frame always MSB is 0. In S
Zero.
frame, first bit is 1, next bit is 0. That means it is S frame. Okay.
Yes,
So your these frames is identified based on this control itself. Okay. Whatever
yes,
control
sir.
fields are there, so based on, so if initially itself I get 0, then I immediately I declare that frame as a I frame. If
I
immediately if I
yes,
get 1, then I look for the second bit, whether it is 0 or 1. If it is 0, then it is S frame. If it is 1, it is U frame. Now
U
it is
frame.
0.
Yes,
So we have 2 bits. The rest of the 2 bits are there, right? In that 2 bits,
yes,
I have to analyze what it is. So if in that, right? So like first that subfield is there, right? That is receive ready. If the value of the code subfield is 00, then it is receive ready subfield. So it is like I'm saying I'm ready to receive that. Okay. So if it is
yes,
like 10, then I'm not ready for receiving new field. Okay.
yes, sir.
So if it is 01, then I'm saying the receiver that please reject this field. Reject field. Okay.
Yes, sir.
If it is 11, then I am saying selective reject. Only particular things you can reject.
Yes, sir.
Clear?
Yes, sir.
So U frame is again like user frame. It can be anything. So it can use for connect, disconnect. You can define any function for this. That is a user defined. Okay. This is very important. Like as we had seen, there are various types of connectivities, right? Point to multi-point. So
Yes, sir.
I gave you one example. For example, Wi-Fi node in your colleges. So you have seen that
Yes,
one node. From that one node, it serves to multiple users. That is multi-point.
multi-point.
Correct?
Yes, sir.
So, for instance, like you have seen that walkie-talkies, right? Walkie-talkie usually
Yes,
it is point to point. One guy will be speaking, another guy will be listening, another guy will be
yes,
this guy will be listening. That is
yes,
point to point, one to one communication. Okay.
yes,
So usually millions of internet users who need to connect their home computer to server using a point-to-point. Okay, so I mean especially the broadband connectivity. So in the remote areas and all, you usually go for the point-to-point. Okay.
yes, sir.
So usually we say P2P or PPP, point-to-point. So point-to-point communication usually it defines the format of the frame. It also defines like how to establish the link between two. Okay, how data has to be encapsulated in the sense like data, then how the headers and all everything has to be there. How devices
Yes,
can authenticate each other. I mean, see, when I'm trying to talk to another link, okay, somebody also can keep his device and connect to that link, right? So we
yes,
need to define how to authenticate and how to make sure that like other end who is connecting reliable person
yes,
like that. Okay.
yes,
So point-to-point networks also provides the address configuration, like how we can have a look at you. You might have seen that know my IP. So you will see that IP address of your local broadband and also. This point-to-point network manages that also, assigning the IP addresses. Okay.
yes,
So in the point-to-point link, first is basically flag. Okay, flag. flag field is again beginning of the frame. So flag byte is 0, 1, 1, 1, 1, 1, 1, 0.
Zero.
Okay. If you see here, continuous 6
5 1.
ones are there. 6 ones.
Okay. Yes, sir.
Correct? So
Yes, sir.
in the data also, if you see 6 ones, what you do? After 5 ones, you will append 1 0. This is called HDLC
0.
stuffing. Stuffing, right?
Yes, sir.
Appending.
Yes.
So in the address field, it is 1 byte. Okay. And that is 1 byte and is always 1. This address is the broadcast address. All the station accept the frame. Okay, in the point-to-point link.
Yes.
Okay, and control byte is also 1 byte. This field uses a format of U frame. Okay, unnumbered. Okay, in HDLC. So if you see here, this control field uses U field format. So you have to see like which is U field format. This one, correct? It is non-sequence,
Yes.
unnumbered. This format it uses. Okay? There is no sequence number. Only in I frame that sequence number is, right?
Yes, sir.
Yeah. So in the protocol field, this field specifies the kind of packet that is like data field, what it is being like, what kind of data it is being. Okay.
Pink.
So the data field is actually variable length. Okay. So default length is 1500. In between that, right, you can have the 1500. So you can have like initially this flag field, address field, control field, protocol field. After that, up to 1500 data you can stuff and send.
Yes.
You can see here flag, address, control, protocol field, and then payload, that is the data what you want to send, and FCS. This is again 2 to 4 byte. It is checksum, CRC.
Yes.
Okay. Finally, 1 byte is flag. What will be there in flag? 0
End of.
followed by 6 ones and 0. Correct?
Yes, sir. Yes, sir.
In the transition phase, what we do, like initially it will not be there. Okay. Then if we detect the carrier, so here actually we have to see. Yeah. First we have to establish the connection. If it is failed, then dead. If the carrier detected again, right, it will authenticate. Okay. So if it is not failed, like if it is established, then it will authenticate. If it is failed, then terminate. If authentication is successful, then form the network. Once that like network layer configuration is done, then it will open. Okay. If authentication is not needed, directly it will establish the link.
Network.
Then open.
Yes. Yes. Yes.
So in the dead phase, the link is not being used. So it is like no more it is there. So it will not establish. So there is no active carrier that is at the physical layer, and the line is white. In the established mode, right? Here established. Once it is established, when one of the nodes starts communication, the connection goes into this phase. In this phase, options are negotiated between two parties. I mean, which channel to choose, which is better, that we negotiate. If the negotiation is successful, the system goes to the authentication phase. So in the authentication is like it will check for the keys. If both the parties are agreeing, then it will establish. Authentication basically, two nodes may decide during the establishment phase not to skip this phase. However, if they decided to proceed with the authentication, they send several authentication packets like encryption and all, password, all this stuff. Then they will establish the network. So in the network phase, negotiation for the two network layer protocol takes place. So point-to-point protocol specifies the two nodes to establish the network with the agreement. Okay. So then it will start establishing a link and start communicating. Okay.
Yes.
So in the point-to-point protocol stack, we will have 3 layers. One is link control layer, authentication protocol layer, network control protocol. Okay. Here in the link, so this all we are talking about HDLC protocol. Okay. That is in, now we are talking on the which layer?
A data link layer.
Correct. So in the link control protocol, It is responsible for establishing, maintaining, configuring, and terminating the link. Okay, if you want to form the link, if you want to configure the link, or if you want to establish that link, or if you want to terminate, all these cases we use link protocol. Okay.
Yes.
In the authentication protocol, basically password or like challenge handshake, right? So it is like it's a straightforward, name itself indicates. Correct?
Yes. Yes, sir.
Yeah. So on this authentication protocol, maybe we'll discuss. So first is basically password authentication. So here usually, I mean, as we know, like we are the excessive user of social media. We'll be knowing this, like username, password provided by the user who wants to access the system. The system checks the validity of the username, password, either accepts or denies it. Okay. So PAP packet
Yes.
usually authentication request. So it sends username and password. Authentication acknowledgement, the system will acknowledge whether these two are valid. If it can allow the access, he will send it. So if you want to deny the access, he will send authentication. And another is challenge handshake. So it is like more secured than your password based. Okay. In this method, like password is kept secret and it is never sent online. Here there is a three-way handshaking authentication protocol. So here system sends the challenge packet to the user. This packet contains the value, usually a few bytes. Using the predefined function, user combines this challenge value with user password and sends the resultant packet back to the system. So here password directly we are not sending, because as you know, on the network itself can someone hack, right?
Yes, sir.
So what happens, like the system sends some challenge pattern. So you will merge that challenge pattern plus the password, and you will form new byte. So that new byte you are sending to the system, so that like nobody can hack it. Okay.
Yes, sir.
So challenge used by the system to send the challenge value. That is actually one way. Another is response used by the user to return result of the calculation. Success used by the system to allow access to the system. Failure used by the system to deny access to the system. In this sense, how we follow actually, like we can use challenge directly, and you can create a new packet, or like whatever the response we get it right from the system, that we can use to create a new packet, or like whatever success we get after authentication, that we can use in the system to form the link. Or finally, if it is failure in all the cases, then we deny, right?
Yes, sir.
So here we compare. So we saw like two types of protocol. One is HDLC and point to point. So in HDLC, basically it is a bit oriented. Here P2P, it's a byte oriented, right?
Yes, sir.
So HDLC usually it will be used in synchronous media. Here it is synchronous. Listen, here it doesn't matter much about clock. I mean, it is asynchronous. Okay.
Synchronous.
So HDLC, there is no authentication mechanism. Here we have more authentication mechanism.
Yes, sir.
Here does not offer the dynamic addressing. I mean, whatever the address your local PC has, that has to be fixed. It doesn't offer like a time to time changing. In the point to point way, we have dynamic addressing mechanism.
Yes.
Okay. On the multiple access, maybe we will discuss tomorrow. Okay.
Yes, sir.
When is the exam actually? On that end also we have to be a little track.
Like, sir, like July last week or August first week, sir. Like, they have not told the date. They have told that from July 26th the exam starts, sir.
Okay. Okay. Okay, no problem. Here, I mean, maybe in next two classes, this third unit will be completed. Fourth unit, I think it will be straightforward, right? Network and the class layer will be very short session.
Yes, sir.
That will be easy. But then we will solve some problem. Okay.
Yes, sir.
Okay.
Okay. Thank you.
Okay. Thank you.